In example 12, we have sketched the graph of y is equals to 4x minus 2x squared minus 3, and find the coordinates of the turning point and write down equation of the line of symmetry. Write down the equation of the line of symmetry. First of all, sketching. This one is just a normal quadratic equation, only that the terms have been interchanged. So if we write it normally, we're going to have minus 2x squared plus 4x minus 3. And of course, you can see the value of a is negative 2, which is far less than 0. And of course, the curve must be having an N shape. Let's talk about the y-axis intercept. The y-axis intercept. It happens when x is equals to 0. And at that point, we need to come up with a set of axes here so that we can be detailing it on how we find and what we find. So when x is equals to 0, then you have y is equals to 0. The whole of this term becomes 0 plus 0 minus 3. So y is equals to negative 3. So the coordinates of the y-intercept is 0 minus 3. Let's consider it to be there. That is the y-axis intercept. What about the x-axis intercept? This one only happens when y is equals to 0. Anything along this line, in fact, this line is called y is equals to 0. And this line is called x is equals to 0. X is equals to 0. It is the y-axis, yes, but the mathematical name of that axis is x is equals to 0. This is the x-axis, yes, but the mathematical name is y is equals to 0. So when y is equals to 0, we are now looking at the whole of this function to be equals to 0 minus 2x squared plus 4x minus 3 equals to 0. It might be a bit difficult to get the factors if we get the factorization method, the factor method approach, but of course we have the quadratic formula. Let's use it. X is equals to minus 4 plus or minus the root of 4 squared, which is 16, minus 4 minus 2, which is a, minus 3, everything over 2a, which is 2 times minus 2, which is minus 4. And of course, this one gives us minus 4 plus minus. Let us look at this root part. 16 minus, what is this? 6 times 4. This is positive 6 times 4, which is 24. So 16 minus 24 is negative 8. Everything over 4. Something very important, before we go further, it is important to note what is under the root and negative 8. And because we do not have the square root of negative numbers, it means, therefore, there are no solutions to these particular expressions. What does that mean, there are no solutions? That means the graph does not meet the x-axis. And when it doesn't meet the x-axis, yet we know the solutions of any quadratic function are realized when the quadratic graph cuts the x-axis, and they are called the roots. That means it is shouting very, very loudly that this function has no solutions. Other books will say it has no roots, which is okay. It does not meet the x-axis. But again, we have the shape and we have at least some particulars of the graph. But what are the coordinates? What are the coordinates of the turning point? The coordinates of the turning point, unless we complete the square, minus 2x squared plus 4x minus 3. Completing the square means, first of all, let us make the coefficient of x squared 1, minus 2 gets out, x squared. of course, we are going to have minus 2, such that when you open the bracket, you're going to be left with a positive 4 minus 2x minus 3. That means what? We can now complete the square of that particular part. So minus 2x minus 2 over 2 is 1 squared minus 1. Of course, the 2 affects until this part, so finally minus a 3. So when you open the bracket, you're going to have minus 2x minus 1 squared, of course, plus a 2 because of negative 2 times negative 1, and it gives us a 2. Then finally minus a 3, which is over there. So the final expression after completing the square becomes minus 2x minus 1 squared minus 1. This one is already in the form of ax plus p plus q. And we were told in the previous example, if you can be able to complete the square to this format, then the turning point give us the coordinates of minus p q. So ours is minus 2x minus 1 squared minus 1. So the coordinates of the turning point is minus 1, which is 1, q, which is negative 1. The turning point having the coordinates 1 and negative 1. So we can already say we are talking about 1 and negative 1, that particular point. So our graph can have that shape. Remember, it doesn't meet the x-axis anywhere, and that is why it has no solutions. So if that is the turning point, of course, we were told that in the previous example, the turning point, the quadratic graphs are symmetrical, and the line of symmetry passes through the turning point. So it passes through this particular point, and this point coordinate is 1, negative 1. And since it is a vertical line, then the line of symmetry is x is equals to 1. That is the equation of the line of symmetry. I think we can give it a different approach. I don't know how we can give it a different approach. Remember, we do not have solutions to this particular graph. That means the other approach of the line of symmetry being halfway between the solutions, this one, it doesn't work here because, by the way, we don't even have those solutions. We don't even have those roots. So we can only rely with completing the square and getting the equation of the turning point. And since we know the shape of the graph, then the turning point is at the point 1 minus 1, and the line of symmetry is parallel to the line x is equals to 0, and it is passing the point 1, negative 1. So obviously, this is the equation x is equals to 1, which is the equation of the symmetry or the line of symmetry. Okay?